this video, you will learn about the arithmetic series. So this time, we will apply the formula for the arithmetic series to answer some problems. So arithmetic series. So here the formula to be used for this lesson is first the S sub n, which is equal to n times the quantity of a sub 1 plus a sub n all over 2. While the other formula is S sub n, which is equal to n times the quantity of 2 a sub 1 plus the quantity of n minus 1 times d all over 2. So now let us talk about how we will be able to apply such formula and what is the appropriate formula for one particular situation. So the first formula right here is usually applied when the information given in the problem are those values of the first term and the nth term. So meaning we are given with the information of the a sub 1 as well as the a sub n. While in the other formula, so here we must have a known information with regards to the values of a sub 1 and the common difference. And to further understand the idea regarding the use of these formulas, so let us proceed with examples. So here in this problem about the arithmetic series, we would like to find the sum of the first 18 terms of an arithmetic sequence having the first term of -6 and a common difference of 7. So to start with the solution, let us write first all the information that we can gather out of the problem. So in the problem, we would like to have the sum of the first 18 terms. So that means the series consists of 18 terms, writing S sub 18. So next, another information that we can gather for this problem is the value of our first term, which happens to be equal to -6. So we must write the information about the a sub 1, which happens to be equal to -6. Another information is about the common difference, which happens to be equal to 7, writing d equals 7. So regarding the correct formula that we can use to easily answer such problem is the second formula. So the formula is the S sub n, which is equal to n times the quantity of 2 a sub 1 plus the quantity of n minus 1 times d all over 2. So all we need to do is to apply the substitution property. So that means we will change the value of the a sub 1 to -6, as well as changing the value of b to +7 in our formula. Doing so, we have our problem to solve for the sum of the first 18 terms of the arithmetic sequence. So changing the n to 18. Doing so, the n here also changes to 18. And now we have our 2 times the a sub 1, which happens to have a given value of -6. And for the n, again, this is 18. While the common difference is given to have a value of 7. So this will be all over 2. So next would be to simplify the resulting equation here. So working on the right-hand side of the equal sign, we have this 18. So we can divide the 18 immediately by 2. So 18 divided by 2 gives us 9. So writing the answer here. So next, so inside the parentheses, we can immediately proceed multiplying the 2 with the negative 6, and that gives us negative 12. While here we have 18 minus 1, which happens to be 17. So writing the answer here. And then we must multiply the 17 with 7. So since we no longer have the denominator, so we must proceed with the next step. So again, to further simplify this one, we would like to have the 17 be multiplied with 7. So that gives us 119. So anyway, we can do some scratch work here to check whether the answer is correct. So doing so, we have this to be equal to 49. So 7, then we have an 11. So 119 is correct. So then, adding these two numbers together, we have the value of 107. And finally, we can come up with the answer by multiplying the 9 with 107. So this would give us 963. So anyway, let us perform some scratch work here. So 107 times 9 gives us, so this gives us 63. So 963 is correct. So that means the sum of the first 19 terms of the arithmetic sequence with this information gives us the answer of 963. And let us proceed with another example. In this example, we would like to find the sum of the first 27 terms of an arithmetic sequence having this information. The first term of negative 13 and a 27th term of 91. So writing the known information with regards to the problem, then we have the sum of the first 27 terms having the first term of negative 13, having a 27th term, so 8 sub 27, which happens to be equal to 91. So since we are given with the information of the a sub 1 as well as the a sub n, then we will be using the shorter formula for this. So again, the formula is s sub n equals n times the quantity of a sub 1 plus a sub n all over 2. So we will merely use the same idea for this, and that is by the use of substitution property. So having our a sub 1 be equal to negative 13 while the a sub 27 be equal to 91. So changing all of those here in our formula, we have our s sub 27 for our question, while the n changes to 27. So this will also be 27. So we have our a sub 1 to have a given value of negative 13, while the a sub n to have an equivalent value of 91. And now, let us work on the equation. So here on the right-hand side of the equation, we will have our negative 13 being added to 91. And that would give us 78. And here we can now apply the cancellation method by dividing the 78 by 2, which will give us 39. And finally, we have to multiply the 27 with the 39. And so let us have our scratch work here. So here we have, so this gives us 1053. So that means the sum of the first 27 numbers of this sequence is equal to 1053. And let us have another example. So here we would like to find the sum of the first 36 terms of the arithmetic sequence. So having the information about the first few terms of the arithmetic sequence, so the information that we can gather for this problem obviously is the first term of 48. So while we are not given directly with the value of the 36th term as well as the value of the common difference, the easiest way to come up with one of the required values in any of those formula is to have the value of the common difference, because it only requires us to use whatever consecutive numbers do we have in the sequence. Like for example, the common difference can be obtained by having the a sub 2 minus a sub 1. So which happens to have the value of 31 minus 48, and that would give us negative 17. So here, the value of the common difference is negative 17. So another important information is the problem obviously is the value of the a sub 1, which happens to be equal to 48. So with both of these values, we can now use the longer formula to come up with the sum of the first 36 terms of this sequence. Doing so, we have the formula here. And now for the substitution property. So we must have the S sub n to be S sub 36. So remember, our problem would like to have the sum of the first 36 terms. So since the n changes to 36, this will also be 36 together with this one. And so we have our 2 times the value of a sub 1, which happens to be equal to 48, while the n changes to 36. And for our common difference, it has a computed value of negative 17. And that completes the substitution. And now let us work on the resulting equation here. So we may directly divide the 36 by 2. And that gives us 18. So next, we can multiply the 2 with the 48, giving us a product of 96. While this is obviously 35, and such 35 will be multiplied with negative 17. Sorry. And now let us simplify the resulting equation. So here we have 35 times negative 17. So let us do some scratch work here. And that gives us negative 595. So we are multiplying a positive with a negative number. And now it is time to have the sum of these two numbers here. And we have this to be equal to, so let us do some scratch work here. So we will apply subtraction obviously because we are adding two unlike sign integers. So we have 499. Sorry, negative 499. And finally, we will multiply these two numbers for our final answer. So let me just the answer be written here. So let us continue here, somewhere here. So doing some scratch work first. So we have 499 times 18. So we have this to be 72. This is another 72 plus 7, 70. So while this is 32 plus 7, 39, and we merely copy this one. And adding all these numbers together, we have 8,982. So for our final answer is negative 8,982. And that would be our sum of the first 36 terms of this arithmetic sequence.